life expectancy is some vital statistics, and other vital statistics have to do with death. We're going to focus on that, and travel risk, quantifying travel risk. So this is some data. It's 20-year trends in automobile safety. So we have 2 different years, 20 years apart, hence the title. We have the U.S. population in millions, the number of traffic fatalities, the licensed drivers in millions, and the number of vehicle miles in trillions. So notice these aren't all on the same, what we would call scale, but it is so at least like they're all the same, meaning like each of the vehicle miles is that many trillion, and each of the U.S. populations are given in millions so that we can better compare them. Now let's do some calculations. So we're going to calculate the fatality rate in deaths per 100,000 licensed drivers for 2015. Okay, so here is the big idea. Deaths would be fatalities. All right, and 100,000 licensed drivers isn't what we have, but we do have 218 million. So we're going to work through a few different ways to get the answer here. The way the book teaches this, and the way I was originally taught, is we put deaths on top, right? Because that's what's mentioned first. Per is division, and then we don't have 100,000 deaths or 100,000 licensed drivers, but we start with what we have. We have 218 million. So let's put in all those zeros: 1, 2, 3, 1, 2, 3. And this is 0.000160097. This is not our answer. This is the fatality rate per 1 licensed driver. So not everybody passes away in a car accident. That's great news. And then what we can do is take this number and multiply it by 100,000. We normally don't get just multiply by whatever we want to, but here we can, and we get 16.097, which we would likely round to just 16. Why does this work? The implied thing going on here is that this is really 100,000 over 100,000. So this is 16.0097 per 100,000, right? And you can multiply by a fraction as long as you have the same numerator and denominator. So multiplying by what we will want the per, in other words, in the denominator to be, will get us that number. So that's one way to think of it. Another way to think of this would be to actually figure out what this number 218,000,000,000 is in terms of number of groups of 100,000. Isn't that strange? So if I knew how many groups of 100,000 they were, that could go on the bottom, and I could divide by that and go straight to my answer. So some of you are like, why are you confusing us? But some of you will appreciate this. All right. So 1, 2, 3, and one more. So there's 2180 groups of 100,000 in 218 million. So I could do this as 35092 over 2180, and we're going to end up with the exact same thing. So I can either know how many 100,000s or whatever I'm looking per in the bottom, or I can know deaths per licensed drivers and then convert to the per so many with multiplication. Now this is got a lot more applications, but some people find that as a really weird step, so I wanted to show you another option if you felt that way. Next things next. This is also an explanation of why we don't do fatality rates per person and why we don't necessarily leave it this way. These are big numbers, and we already said like quantifiably we don't always make the connections from statistics to risk, whereas this is a number that's just easier for us to comprehend. There are 16 deaths for every 100,000 licensed drivers, and we can think about like how big would a city be to have that many licensed drivers and get a better grasp around what that means numerically. Another thing we can do is take this data and make it work for whatever size group. So we know that there is 16 fatalities per every 100,000 licensed drivers. That's what we learned just a second ago. And if we know that there's 2.4 million licensed drivers in Arkansas, which there was pretty recently, how many traffic fatalities could we expect in Arkansas? So again, this is 2015, so all of the data works in terms of the same time frame. And just like up here, to get it from deaths per person to deaths per 100,000, we multiplied by 100,000. We're going to do the same thing here. So we're going to multiply by 2.4 million. So that's 2, 4 with 2 zeros, 3 more zeros, and now we have 2.4 million. Now those are some big numbers to work with, but it gives us around 386 traffic fatalities that year. Now again, this is per all Arkansans, which is why we multiplied by 2.4 million and didn't just magically come up with that number. Okay, so you can get the rate per person, that's what we had here or here, and then multiply by however many you want it to be per, because of beautiful fraction rules, and have that. Now, we saw right here that working with real live data comes with huge numbers and pretty small numbers, right? This is a pretty interesting number to try to compute in our head and make sense of. So what do we do when we come up with those types of numbers? Well, we can do what we did here, change it to per 100,000 licensed drivers, or per the state of Arkansas, however many are in there. Another thing we can do with it is scientific notation. So we're going to review some scientific notation in the next video and just work with some more ratios inside that fun scientific notation.